Okay, to start with, a couple of facts. The weight of an object, not necessarily a person, the weight of an object is the downward force on that object. And Newton's second law can be turned into the equation F equals ma. Force equals mass multiplied by acceleration. Now, when we look at this force, this downward force, which is known as the weight of an object, that weight is equal to the mass of the object times its acceleration. And we know, and we have done experiments, and you will end up doing them in physics if you haven't done them already. There are 2 experiments on our course to calculate the value of the acceleration due to gravity on the Earth. So the acceleration due to gravity we normally refer to as little g, and it is approximately 9.81 meters per second squared. Okay, now we want to talk now about an object that starts from rest, in other words from 0 meters per second, and starts to fall. So we need to look at the forces on that object and work out what exactly happens at the different stages of falling. So hopefully everybody would agree it falls from rest, so its initial velocity is 0. And now let's look at the forces. It has a force downwards of its own weight, but it will also have a force upwards, and we will call that force Fd. D being for drag, the drag force on the body. Okay? Now, hence the overall force on that body in a downwards direction, the overall force on that body, we could refer to this in other words as just an F. Okay? The overall force on that body, hopefully everybody would agree that F is equal to mg minus Fd. So the downward force on a falling body is mg minus the drag force. Okay? Now, another important fact is that the drag force, in the case of a parachute in particular, is proportional to the velocity of the object squared. Okay? Now, that means that Fd, the drag force, is equal to some constant times v squared. And that's an important point to note. Okay, so as the object falls, okay, its velocity increases because initially there is no drag force and the object is falling. Okay, so if there's no drag force, it initially starts to accelerate at 9.81 meters per second. And acceleration, as everybody should remember, is the rate of change of velocity. So it's the change in velocity divided by the change in time. So its velocity is increasing in a downward direction as it falls. It is getting faster. Now, but, okay, the drag force is proportional to the velocity squared. So as its velocity increases, this drag force also increases. What does that mean? Well, the overall force on the body is mg minus Fd. So if the Fd gets bigger, that means the overall downward force on the body decreases as Fd increases. Now, again, by Newton's law, if we have the body accelerating downwards due to a force F, we know that that force F which is the sum of these two, okay? It's the downward one, take away the upward one. That F, as the object falls, that overall force is equal to the mass of the body multiplied by its acceleration, okay? So now it is no longer accelerating downwards at an acceleration of g, remember, because now it has an upward force and a downward force combining to give this F. So this F divided by the mass of the body is the actual acceleration of the body. And as we said, if Fd increases, the overall force is decreasing, which means the body is accelerating at a lower rate. Now be very careful here. Accelerating still means its speed is increasing, but it's increasing at a slower rate. Okay? Now, eventually then, A is getting smaller and smaller and smaller. This force is getting bigger and bigger and bigger. And what eventually happens is that when Fd is equal to mg, which it will do because Fd increases as the velocity increases. And the velocity is increasing all the time until Fd reaches the same value as mg. Because what happens then? The overall downward force on the body will be mg minus Fd. But with Fd equal to mg, it will be equal to 0. Now we have a body that has a downward force of 0. The mistake students make is they assume that this means the body is not moving. Not true. The body is not accelerating. Its velocity is not changing. Its velocity is now constant. Okay? And that's the interesting thing. We'll call the constant velocity Vt. Because now, if its velocity is constant, the Fd isn't going to change anymore because it only changed when the velocity changed. So Fd will remain at that value. Mg is a constant value, the weight of the object. So for the rest of that object's flight, it will fall at a constant velocity of Vt. Vt being the velocity that made the drag force equal to the weight. And we will now talk about how that can be used in order to predict the area for the parachute.